Okay, so I made this pre-recorded session for you guys to have um certain ideas on what is the application for exponential function. So let's have this one fast. Okay, for the exponential function and its application, we are dealing with exponential growth and exponential decay. So that is their application. So at the end of the session, the students will be able to determine the properties of the exponential function and its sketch or the graph. Okay, and solve problems involving exponential function. So I prepared five examples on the application for exponential function. Okay, for exponential function, I'm just gonna be fast on this one because I know that you guys already know exponential as of its form. So exponential function are functions whose exponents are variables that are unknown and the base is any positive real number except for negative, except for 1. Okay, so I'll just be putting all the properties here and know that there are four properties involving like this one. For example, this is y equals b to the power of x, and that is b is greater than 0 and not equal to 1. So if our base is greater than 1, that means to say that our graph is increasing. So, ganun siya. Pag 2, 3, up until positive infinity, our graph is increasing in the motion or the behavior. And then the asymptotic is on the x-axis and it is approaching to negative infinity. The second one is the same as the other one that passes through 0 and 1. Again, so the only difference is that when the base is in between 0 and 1, that includes our numbers such as fractions 1 half, 1 third, but not in 0 or 1. So, ganun siya. That is decreasing order. And then, again, it is asymptotic, asymptotic to x-axis and then it approaches to positive infinity. And then the graph is continuous. And then also it is smooth. So these two here, two sets. The only difference is that we now have a paired with a, I mean, multiplied with b, such as that a is an element of real number. Okay, so ganun na siya. And then the only difference is that it passes through 0 and a, compared to the other one that is 0 and 1. So again, they are the same as of the graph is increasing if b is what we say as greater than 1, and then it is approaches to negative infinity. The other one, okay, I'm just going to be fast on this one because these are all verbatim. So after I uploaded this one to your classmate, or let your classmate upload this one, this will be like reviewed ahead of time or many times. For the other one, that is our graph is decreasing if it's in between or the base is in between 0 and 1. Again, just the same with the other one. Then it approaches to positive infinity. For example, we have y is equal to 2 to the power of x, and we have the other one, y is equal to 1 half to the power of x. So you might be wondering, hala, sir, our answers, sir, are quite different with what is expected for us to answer. Good thing I'll be giving you another chance, a 1 day, for you guys to check if your worksheet number 5 is already been correct in the form of this one. So pag mali pa, you have the chance to change. So if you wanted to turn it in again, much better. But if you're confident enough, then don't touch it anymore. So you'll be proceeding with worksheet number 6 right after the video is uploaded. Okay, so this one, domain is set of all real numbers because you might be answering me in like domain or like -3, -1, 0, and 1. So that's gonna be a problem. And then the behavior of the graph is increasing. Why? Because our base is 2, and that tells us that the b is greater than 1. So we are following the rules. And then the second one, which is 1 half, we directly know that the only difference is that it is decreasing and they have the same properties at the moment. You might be asking questions, sir. Should we be able to provide you a solution with the f of x or the y? Yes, a two-liner solution will do. Like for example, y is equal to 1 half to the power of 0, and then the other one is y is equal to 1. So directly answering me with that, that is already been accepted as correct. So ganun na siya, small solution or like a simple solution will do. So the only difference is that the first one, sorry, this is supposed to be second example. So number one and number two, or example number one and number two, tells us that the first example is increasing, and then the other one is decreasing. Okay, so ganun siya. For the application, let's proceed to the exponential decay and the growth. So we'll be answering this one right after we will be able to know the properties. I mean, sorry, the ideals or the definitions of what is the exponential decay and exponential growth. But then we will just be reading this one. Have you ever noticed the green colored molds in a bread that was spoiled? And on the other one, do you think 100% of the medicine will still be in your bloodstream right after 10 days you've taken it? Okay. So the definition of the two is that exponential growth, as we know from the root word growth, it describes the increased number or the size or, for example, population that is constantly growing at a certain rate. On the other one, the decay, which in fact tells us that it is reducing amount of consistent percentage rate over a period of time. So they are contrasting, since the idea here of the growth is plus and then the other one is subtract. So the general equation tells us the growth, yeah, tells us that P of t is equal to P initial quantity 1 plus r to the power of t over c. And then for the exponential decay, we have P of t is equal to P initial quantity 1 minus r to the power of t over c. So they have the similarities. In fact, the decay uses subtraction because, yeah, it is a decay. Where P is the population and P initial, yeah, P of 0. R tells us the percentage rate in decimal point. C is for cycle, and the amount of time that is for t. So we will be proceeding with our first example. Now know that first example is interconnected with what your mini task 2 is adopted. Like for example, you are going to be finding the equation or the model, and then the second one is you're going to be graphing, and then the other one is you're going to be finding what is the expected population of a certain barangay in Cagayan de Oro. Like this one, the population of a town is estimated to increase by 15% per year, so they have a constant rate. The population today is 20,000. What will be the population by 10 years from now? So the given is 0.15, that is for the rate. And then C is for the cycle, because why? Why 1? Because the cycle is per year man, so that tells us that one should be used. And then P initial is 220,000 rather, and T is for 10, that is 10 years from now, and we are asked to find the population. That is why we're using the population growth, exponential growth, sorry. So P of T is equal to P initial quantity 1 plus r to the power of t over c again, so we'll be directly substituting it. So in the first line, you can answer me like this one. P of t is equal to 220,000 quantity 1 plus 0.15 to the power of t over 1. That is 20,000 quantity 1.15 to the power of t. So you might be asking, sir, why did you even presented this one? Because we're only asked to find the population man. But then there are questions like you're asked to find the exact model of the problem. So that's why I presented this one. But if it doesn't require you, so you can directly answer me in like P of 10 is equal to 20,000 quantity 1.15, since I've already understand that you use that one to the power of 10. Question, sir. Um, if our answer is in decimal point, what should we be doing? You will be rounding your answer into the nearest whole number. So that's why it is really ask of you guys to like know how to round off. Like for example, 315.95. So directly it will be 316 because we'll be asking of the whole number man, because it deals with the population. We cannot use decimal point as the final answer because we are dealing with lives. Okay, and a human is accepted as one. So therefore, the town will have 80,911 people in 10 years from now. Example number 2, that is for bacteria. A model of bacteria, or for the bacteria population after T hours, is given by P of T is equal to 1,000 quantity 2 to the power of T over 3. Okay, question. Sir, what if um the model is given already? Then you don't have a problem at all. So you can directly answer with A and B problem. So on that case, if the model is already been given, so you can directly do it. But then, if not, so you'll be having the general equation as for the basis of your answer. But then, as we can see here, that the model is really pertaining to the general equation, although it somehow been changed because there is already been simplified. Okay, so how many bacteria are present in a colony after 15 hours? And then the second one is what will be the count rate of the bacteria after, I mean, what is the time if the bacteria will be at 128,000? So our answer is the bacteria population after 15 hours is 32,000, and then the bacteria level reaches 128,000 is after 21 hours. But how? So the first one we're gonna be answering is that yeah, we'll be using the P of t is equal to 1,000 quantity 2 to the power of t over 3, where t is 15 hours. That is the given. So directly answering it with P of 15 is equal to 1,000 quantity 2 to the power of 15 over 3. Okay, so divide 15 with 3, that is 5. So P of 15 is equal to 1,000 quantity 2 to the power of 5. So again, sir, question, what if we multiply 2 and 1,000 directly? No, we will be using the process of the GM does, where in fact we'll be accommodating first the parent, I mean GM does. Okay, PEM does. So we'll be having first the exponent, right? After we multiplied or have the operation of multiplication. So 2 to the power of 5, that is 32, multiplied with 1,000, that is why we will be having 32,000 for the number of the bacteria.